This video is going to be on section 1.2. Again, we're looking at your homework number 5 and or number 6. In this video, we're going to find how to tell if you have a function using a graph. Now, we're going to be using what's called the vertical line test. Vertical line test says that if you drop a vertical line and touch the graph in only one place, the graph is a function. If you touch in more than one place, then you have a relation. So let's look at the graphs that we have here. In problem number 1, if I drop a vertical line, I touch in that one place, so that would be a function. Number 2, if I drop a vertical line, I have touched here and here. That would be a relation. Number 3, drop a vertical line, you would touch one place, that would be a function. Number 4, now be very careful here. If I drop over here, that's 1. If I drop here, that's 1. But you can't pick and choose. You've got to say, is there any place that would be two or more places? So if I drop my vertical line here, notice I have just touched the graph one place. Continue your line and you have touched 2 places. That is a relation. Number 5, if I drop here or if I drop on the other side, I've touched one place only. That is function. Number 6 is a little tricky because if I drop one place, now I have touched. If I continue to drop, I go through this open circle, which means I have truly not touched a graph anywhere. Now these were 2 closed circles, so I touched here and here. One place here, I did not touch the open circle, that would be a function. Number 7, I touch one place, that is a function. And number 8, a circle, that's 2 places, that would be a relation. Vertical line test says if you touch one place only on a graph, you have a function. The next part, and this is very, very, very important, is finding domain when you're given an equation. I'm going to tell you that if you'll look in the rules, I have really made this simple for you right here. If you copied off my papers, you have this. Finding domain, there are 2 trouble spots. 1 is a fraction, 2 is a radical. If you have a fraction in the problem, you're going to set your denominator not equal to 0 and simplify. Remember, you cannot divide by 0. Second, if you have a radical, you're going to set the radicand, that's what's underneath the radical, greater than or equal to 0 and simplify. If you do not have either radical or fraction, then the domain is the set of all real numbers. Now remember, domain is what you can put into the problem for x. Now, because of space, I'm going to write these on just a clean sheet. I'm going to take what you have. And number 1, when I look at this problem, I'm looking for domain. I do not see a fraction. I do not see a radical. Then the domain is all real numbers, which means any number can work for x. Now this is the symbol. If we use interval notation, that would be from negative infinity to positive infinity. Okay? Secondly, the next problem is this. F of x equals square root of x plus 1. I do not see a fraction, but I do have a radical. And remember, from the other page, it says to take the radicand, set it greater than or equal to 0, and let's simplify. That would be x greater than negative 1. In other words, what numbers would work? Well, a negative 1 would work, and any number bigger than negative 1. Now, in interval notation, that would be any number beginning at negative 1, inclusive, and going to positive infinity. Infinity will always carry a parentheses. The next one would be f of x equals x plus 1 over x minus 6. Right off the bat, you see, hey, I have a fraction. Now remember, with a fraction, it's the denominator that's my problem. So you take the denominator, set it not equal to 0, and simplify. So x cannot be a 6. Now, how do I write that as an interval notation? Well, it's any number from negative infinity up to 6 with a parentheses. Parentheses says I'm not including plus is the set of numbers from 6, not including a 6, to positive infinity. Now what this does is to omit the 6. So any number in the numerical system would work as domain except 6. The next one you have is this problem, f of x equals square root of 25 minus x. Now again, you see a radical. So you take your radicand, set it greater than or equal to 0, and let's solve. Now I'm going to move the 25 across. It becomes negative 25. Remember, we cannot stop this with negative x, so we divide by a negative 1. When you divide an inequality by negative, you reverse the signs. So I have x less than or equal to 2 negatives, positive 25. Now this says that any number smaller than 25 will work, or equal. So that means that any number below 25, 25 being the highest number, and any number smaller than that would be negative infinity up to that number. Your next problem is f of x equals negative 5x minus 3. I have no fractions. I have no radicals. So my domain is all reals. Remember, any number, negative infinity to positive infinity. The next problem is f of x equals x minus 7 over x squared plus 2x minus 15. Now I have a fraction, and my problem in a fraction is the denominator. What you need to do now is think about this in simplified form. We can factor that into 5 and 3 would give me 15. The 2 needs to be positive, so that would be positive 5, negative 3. Now, remember with a fraction, you set your denominator not equal to 0. So I set both of those fractions not equal to 0. So x cannot be negative 5, x cannot be positive 3. Now, I'm leaving out this number and this number on a number line. So I have negative infinity up to negative 5 plus negative 5 up to 3 plus 3 through positive infinity for my answer. One more, number 7, f of x equals square root of 2x plus 5. You have no fraction, you have no radical, so your answer is all real numbers, negative infinity to positive infinity.